There is one other thing that we said initially we were going to look at, namely to what extent airflow was responsible for the performance of zones. So I have the initial setpoint analysis in here, which used temperature, room temperature, to look. Let's make another one, and this one will look at airflows. So I will call this airflow analysis. And there's a fundamental difference between the two, because when I look at temperatures, I'm going to look at absolute values. A room temperature of 75, for example, would be considered acceptable in most cases for a high set point or a cooling set point. But when I'm looking at airflows, the value for the CFM on any terminal will vary over time by definition. So I want to look at relative values rather than absolute values. And let's demonstrate how this works. I'm going to take a look at the dual duct terminals again, and the search type will be again for words, except now I'm going to look for my cold deck CFM, for example. So the zone that was too cold, or rather the zone that was too hot in this case, which will be short of cooling airflow, is the one that we're going to look for. And to see what the cooling airflow is called in here, let's take a quick look at our data. So CD flow, cold deck flow, is what we want to look for. So I'm going to make this a property type in the name, call it CD flow. And then in this case, my set points aren't going to be absolute. So again, I'm going to be looking for words in the name. And the words I'm going to be looking for is desired cold deck flow. So I'm going to make that desired cold deck, and the same thing down here. Desired cold deck flow. And I'm going to call it airflow analysis cooling. Okay? Analyze the data. Same thing again. I'm going to scroll down, copy, go over to Excel, and then maybe I'll make a second sheet. And this is the airflow now. Select everything, reformat it a little bit, and then sort for the worst overall performer. Worst overall performer is going to be the largest score. As we saw with temperatures before, we had scores of 14. This is much more. It's 600. So that's about 6 times the desired airflow. On the right, the average over the upper set point is 2,900. That's 30 times the set point. So even though we were looking for the zone that was short of airflow, let's look at this one first to see why it has too much air, because it's obviously stealing air from other zones. So zone 5141, let's look that up in the template graph and take a look at why it's getting that much air. First thing we notice is that the template graph fails to find cold CFM and hot CFM. So let's look at the naming convention again. Why did we look for cold CFM and hot CFM? And in fact, it's called CD flow and hot deck flow, HD flow. The set points here are called desired CD. That looks correct, but I do see a lot of problems when I look in the problems tab under the set point analysis. So maybe the names are not consistent in this database. Scrolling down, we start with the name cold CFM for the cold deck airflow. And scroll down here and look at some of the other names in different terminals. Cold CFM. And now it's called CD flow. So they're not named consistently. So we need custom properties. And we're going to use a custom property that we're going to call flow. We can do that by going to the very top of the project tree here. And here's a custom property and we can make more of these. So we'll edit this. Up comes a window that allows us to create a new custom property, and we're going to call this cold deck flow. Let's also make another one actually while we're at it and make that hot deck flow. And now we're going to have to assign for ourselves either of the descriptions that were given in the naming convention to those properties. So I'm going to select the properties by looking at all of the channels in the duct terminals and looking for CD flow. That gives me both the set point and the actual values. So I'm going to isolate just the actual values, a little comma and a space before, and show those in the properties for cold deck flow as actual. And then I'm going to go back and select the set point. So I'll take the space away again and the comma and make it desired. And that was my set point. Select them again and make that the value set point in cold deck flow. So I'm using one property but for two states as my description. Then I had the other description, which included the word CFM. So this is cold and hot CFM. So I'm going to call this cold CFM. Select all of these. Now these are also actual flows. So again, I'm going to say cold deck flow actual. And then I'm going to do the same thing for the set points. And these were desired CFM. And they were actually cold deck desired CFM. There we go. Those are all the cold deck set points that were named slightly differently. So I'm going to go into this property and say set point. There we go. I'm going to do the same thing with the hot deck without showing it. Okay, so having reassigned all of these different names to a custom property, let's go back to the VAV chart, and instead of looking by name, let's look by property. So we're going to look for words again, but instead of the original name, we're going to look at cold deck flow, the actual flow value. So there's one, and we're going to do the same thing for the hot deck. Look for all the words, hot deck flow, actual. So that should have set up our zones for better view. It didn't actually change the way the zone looks, ironically, but at least we can now be sure that we've actually got the right values. So with that, let's rerun our analysis as well. Change the settings here from the category name to our self-made property cold deck flow, and this will be the actual value. And then incidentally, we're also going to change this to occupied in the filter, and then do the same thing over here. Change to a custom property and call this set point. And lastly, on the lower set point again. So we've updated the custom properties, and now our worst performer appears to be 5141. It's got a massive error on the upper side, which means it gets too much air, but it's pretty much the only one with that larger result. The next one's a far lower in score. So let's take a look at 5141. Back to the chart. Custom properties, I'm going to select 5141. And as we'd seen earlier, even though it does select the correct values now, there seems to be something wrong with the original data itself. So instead, if we look at the next candidate, that would be 5138. And in fact, here too, the data in the beginning of the time period is missing or erroneous. So this applies to the first few zones in here in the analysis, all the way through 5131, and then as of zone 5209, where we get 0 on the excess air side, we actually get the first if you will, real results. So 5209, when we take a look at that, and we take a look at only the cooling side. So I'm going to unclick the hot deck here. So here we can see the cold deck actual airflows are around 60 CFM when the set point is somewhere up around 300 CFM. So clearly that zone is short of air, and it's one of the worst performers that have real data in them. That relatively small zone is our worst performer, and we've managed to look at the other erroneous zones that were even higher up on the list of set point analysis, but they had illegal data in them. So in that way, despite errors in the dataset, despite errors in the naming convention, we were still able to figure out what the actual performance of the building as a whole was. So there's a variety of tools that you need to use, and not just look at the analysis table that gets spit out by the setpoint analysis, but just like every good computer analysis, garbage in is garbage out, and you do have to go and look at the template graphs to make sure that the results are actually meaningful.